Good morning. Today we are going to be continuing on with our unit over the atoms and periodic table. First, we had talked about our structure of our atom. In our nucleus, we have our protons who are positively charged, our neutrons who are neutrally charged, and then outside the nucleus, we had our electrons that have a negative charge. When we look at atoms, originally, Dalton, remember, came up with the first atomic theory, and part of his theory, he had stated that all atoms of an element are exactly alike. However, we have learned that is not true because we have what is called an isotope. An isotope is going to be atoms of the same element, and they have the same number of protons. However, the number of neutrons vary. So for example, carbon-12, carbon-13, and carbon-14, you've probably heard those in terms of carbon dating when trying to identify how old something is. Carbon-12 sometimes will have 6 neutrons, carbon-13 will have 7, and then carbon-14 will have 8. So when we change the number of neutrons, we are changing the mass of the actual atom. Remember, the number of protons, however, can never, ever, okay, did I say it enough? Ever change. Our protons cannot change because the protons are what identify the element. So when we look on that periodic table and we find carbon, we know carbon will always have 6 protons, and that's it. So reminder, when we calculate mass can be calculated by adding together our number of protons and neutrons. The mass of an electron, remember, is relatively 0, unless if you're going to be a particle physicist or an electrical engineer, you may not even consider electrons' mass. But for us, we give the mass of an electron as 0. Protons and neutrons each have a mass of 1 AMU. That's 1 atomic mass unit. So basically, we say that the mass of a proton is 1 and the mass of a neutron is 1. So when we look at a proton and neutron, both of them are located in the nucleus. The only difference is going to be their charge. They have the exact same mass. Okay? All right, so again, when we look at carbon, carbon has 3 different isotopes that occur naturally: carbon-12, carbon-13, and carbon-14. Since they each have different numbers of neutrons, each of them are going to have different masses. And the masses associated with each are carbon-12, mass is 12, carbon-13, mass is 13, carbon-14, mass is 14. In order for us to get 12, 13, and 14, we have to take our 6 protons plus our number of neutrons. If our mass is already 12, we know that 6 plus 6 will give me 12. If the mass is 13, 6 plus 7 neutrons will give me 13. If the mass is 14, we take 6 protons plus 8 neutrons to give me the mass of 14. So again, remember, carbon has 6 protons. It will always have 6 protons because of its atomic number. Okay? So remember, each of our atoms have protons, neutrons, electrons. The protons, for now, is the same as the electrons. However, now we are learning that those neutron numbers can change. Neutrons, again, are going to affect the overall mass of our atom. All right, so here's calculation we were just talking through. So again, carbon-12, the 6 protons plus the 6 neutrons. Carbon-13, 6 protons, 7 neutrons. And then carbon-14, 6 protons, 8 neutrons. All right, so when we go ahead and we name isotopes, we can actually go ahead and use chemist shorthand, because with our mass, since the mass can be different, we want to make sure that we are specifying exactly what the mass is. Remember, we always have whole numbers because we cannot have 0.5 of a proton or 0.5 of a neutron. So we will always have a whole number. Remember, the symbol is going to be listed for you, which would be C. And then A, if you look, top left, is going to be the mass number, which is my protons plus my neutrons. And then Z, which is down below, is going to be my atomic number. If you notice for each of our isotopes, carbon 12, carbon 13, carbon 14, they each have an atomic number of 6 because they all have 6 protons. Now, another way that we can write this is actually in isotope notation. So if we were to write this in isotope notation, you hear me say this often. This is carbon dash 12, carbon 13. And then our last one, carbon 14. This would be our isotope notation. This would be another way for us to go ahead and denote that I have carbon 12, carbon 13, carbon 14, differing masses, which means that I have isotopes of the same element. Now, you guys did that notation with Science Roxium on Wednesday, so hopefully you remember Science Roxium was SK or Science Roxium-12. Here, I could also abbreviate it as C-12, C-13, or C-14. So there's a couple of different ways that we can actually abbreviate our isotopes and write out their names. We can either do scientific or chemist shorthand, which would be here, or we can use our isotope name, which would be the name of the element dash its mass. So name dash mass, and that will get you the same effect. All right, so you might be wondering, what's the difference between mass number and average atomic mass? Remember, my mass number is calculated by taking my protons plus my neutrons. The mass number is always a whole value. So when you look on your periodic table that you guys have, you're going to notice that the mass number, which is actually written at the top of each element square, there's multiple mass numbers. And the reason there are multiple mass numbers are because those are all the stable isotopes of that element. So you may notice that one will say none. If it says none, then there are no other isotopes that exist naturally. But if you look at a different periodic table, you're going to notice that there is a decimal. For example, carbon has a mass of 12.01. So that is going to be an average of all the isotopes found naturally and their relative abundance. So because it's really close to 12, the most common isotope for carbon is 12. It's a lot more rare to see carbon 13 or carbon 14.